my overview series on value added reports, the gain, and predictive models. The information in this presentation comes from the Ohio Department of Education, SAS EVOS, and my work with the Ohio Regional Data Leads. There are many layers of reporting when it comes to value added, but we're going to talk about value added reports and how it impacts the schools or districts. Those reports are very similar, and we're going to discuss them interchangeably. First, let's talk about what is expected growth. Basically, a student should maintain their achievement relative to other students across the state who took the same assessment in the same year. In other words, are they keeping pace with other students across the state of Ohio? The math behind value added is fairly complex, but it does take into consideration the measurement of error, mobility of students, and missing data among students due to mobility or other factors. We're not going to get into the actual math piece of value added, but trust me, it works. So when we look at our different layers of reporting, we're going to look at the value added reports. What are the trends at my school or schools? And we can look at this also at the district level. But most of our examples are going to be based on the school level. The default view when you get into the dashboard will show the English, math, science, or if it was high school, the end of course, and each grade level. So this example shows a 4th through 8th grade building. If you want to know more about manipulating the actual dashboard, please visit my video on value added dashboard, and I take you through how to work through all the steps to manipulate the views. When you're looking at the views, you're going to see an effectiveness level based on colors. This has changed in 2021 based on state law. Light green and dark green now represent students who met or exceeded expected growth. Yellow through red represents students who may have made less growth than expected, with red signifying very significant evidence that the district students made less growth than expected. At the bottom of this, you'll see the effectiveness bar. The effectiveness level bar represents a continuum of color based on where the value added falls. So if you noted, the expected growth is in dotted line right in the middle of the light green, which has an index of -1 to 1. Dark green is greater than 1, and this little dark green crescent represents an index of greater than 2, meaning there's significant evidence of more than expected growth. We have yellow, orange, and red also has a little crescent sometimes to represent if there is significant data of less growth of an index of less than -4. So there are two models, the gain model and the predictive model. The gain model measures between 2 points and is used only for 4th through 8th grade math and ELA because those have consecutive state testing. We used to call it the multivariate response model, or MRM, but we're going with the gain model since it's a little bit more user-friendly. The other model, the predictive model, is for those testing years where they're not in continuous testing, meaning 5th and 8th grade science or end of course exams. Now, some of you may wonder if you go from 8th grade math to 9th grade algebra, that's consecutive years. But you don't have to do that as a student. So when you get into the end of course, your high school courses, we go from the gain model to the predictive model. And the predictive model is called the univariate response model. Now, the word predictive doesn't mean we're predicting, but I'll explain that more when we get to there. So first, let's talk about the gain model. And the gain model uses what's called NCEs. So when you look at a normal distribution of achievement, when you have all these students taking the same assessment, you'll get a bell curve. And with the bell curve, right in the middle will be the 50% mark, with our high achievers on one end and our lowest achievers on the other. But everyone else is kind of bundled together. And there is really no way to look, to see, and measure because There's no consistent intervals. Because of that, we changed the bell curve into what's called the normal curve equivalents, or NCEs. If you notice, the NCEs line up 50 and 50, the 99th percentile with the 99th NCE, and the 1 percentile with the 1 NCE. Now, why do we do that? Well, if you look at 70 to 80, that's 10%. We'll look at 1 to 10 and 10%, and look at the big interval differences between the two. You cannot compare students' growth with these inconsistent intervals. So by transferring these to an NCE, you'll notice that the intervals are now equal in distance. Not only that, if you look at a 99 percentile, it ends. But NCEs keep going on, in theory, infinitely, and below 1, in theory, infinitely, in the negative direction. So they're able now to measure growth or lack of growth no matter where they are in the continuum based on equal intervals. How does that work? Well, let's say you have a group of students who enter into a grade level, and we'll say 5th grade math, and they enter in an NCE of 38. They exit after taking the state assessment with an average NCE of 41.5. Well, that was a positive 3.6 gain. If they entered with a 38, left at a 35.5, that was a negative 2.4 gain. And if they stayed the same, they get a gain of 0. Well, a gain of 0 is actually the measurement of expected growth. So in these examples, this group of students exceeded expected growth by 3.6, whereas these students who still grew but fell behind the expected growth by an index of negative 2.4. Now, as you see, these numbers won't work out exactly because there is rounding involved. When we move on the predictive model, we're going to have a different view. So let's look at how do we get to a predictive model. We're not guessing. What we're seeing is we have two students. We have Whitney and we have Ethan. We have Whitney's testing history and all the testing history of all the students in the state of Ohio. And Whitney's testing history is going to be grouped in with students of like testing history. We have Ethan and his testing history, and he is going to be grouped with students with all the same testing history as him. So when the students actually take the assessment, we have Whitney's score, Ethan's score, and we have all these other students and what they actually scored. So to find whether or not with Whitney or Ethan or any student met expected growth is you take their actual score and compare it to the average score of all the similar students that Whitney is associated with. You do the same with Ethan, you do the same with student 3, 4, and so forth across the state of Ohio. So if we have a group of students, and let's now use 10th grade or English 2, that group comes in with an average scale score of 688. They exit with an average scale score of 692.5. So that change over time, rounded again, is a positive 4.4. So as we stated before, expected growth is 0. So there's significant index data that shows that these students met or exceeded expected growth. So when we look at the dashboard, you'll actually see both models. You'll see the gain model, which represents the 4th through 8th grade math and science, and the predictive model, scale scores, which is in this case 8th grade science based on this example. We don't see a 5th grade science because the information used here was in 2021, and because of the pandemic, we did not have value added for 5th grade science. You can find this information in a variety of places under the Reports tab on the dashboard. Hopefully, that brief overview of the gain and predictive model gives you a better understanding of the different value-added reports. Thank you.